Fourier series. Fourier series means nothing. This is an infinite series expansion in sine and cos, trigonometric functions, sine theta and cos theta. That means any function you can express as an infinite series in sine and cos using Fourier series. What I am saying, an algebraic function x is there. You can write x as an infinite series expansion in sine and cos. X square can be written, and e power x exponential function e power x is there. We can write e power x in terms of sine and cos as infinite series using Fourier series. Here sine and cos are periodic functions. Periodic function means if f of x plus a equal to f of x, then we call f of x is periodic function of period a. Like that, sine cos are periodic functions with some period. That type of function we can expand as Fourier series. So the Fourier series means simply we can say like this: an infinite series expansion in sine and cos. Very simply we can say like this. And the Fourier series of one function in particular integral, say 0, 2 pi, is defined like this. I am taking 0, 2 pi interval, like c, c plus 2 pi Euler's formula, we say that one. That formula, how it will be in a particular integral 0, 2 pi. Interval is 0, 2 pi. Here, formula for Fourier series. This is standard formula. F of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. an cos nx plus bn sin nx, where a0 1 by pi, the given interval 0, 2 pi f of x dx, and an will be 1 by pi integral 0 to 2 pi f of x cos nx dx an, and bn 1 by pi integral 0 to 2 pi f of x sin nx dx. So using these formulas, we can easily evaluate Fourier series of any function in 0, 2 pi. So using this formula, you can evaluate Fourier series of f of x equal to x in 0 to 2 pi. Fourier series of f of x equal to x square, f of x equal to e power x. Any function you can evaluate. So simply we have to evaluate a0, an, bn values. Next, using these formulas, we have to substitute here. If possible, expand by giving some values for n. Because infinite series we cannot give all the values for n. Give some values for n, you will get exact Fourier series of given function in a interval. Very clear? So this is the fundamental formula to find Fourier series of any function. So Fourier series of a function evaluating means mainly evaluating a0, an, bn. Finding a0, an, bn, which gives you complete Fourier series. But coming to this interval, why I select this interval? 0 to 2 pi. This is the interval where you have to find 3 constants. There are some other intervals, minus pi to pi, 0 to pi, that you are not going to evaluate complete. In the case of 0 to 2 pi, no need of thinking any other formulas. you have to evaluate all a0, an, bn. Which interval? 0 to 2 pi. But in the case of minus pi to pi interval, if problem is given in this interval, then you need to check whether function is even or odd. If it is even, the formula is not come to evaluate all the values. You are going to evaluate a0, an only. If it is odd, you are going to evaluate only bn. Like in 0, pi half range cosine series. Cosine series means formula up to here. Sine series means you will get only bn. That we will discuss very detailed in next classes about even odd function, half range, cosine, sine series, everything. But now are you clear? What is Fourier series expansion in 0 to 2 pi? How to evaluate a0, an, bn in this interval? What is Fourier series? Are you clear? Any doubts you may ask. Find Fourier series of f of x equal to x in 0, 2 pi. In that interval, we need to find Fourier series of the function f of x equal to x. First write what is Fourier series of f of x. The Fourier series of f of x in 0, 2 pi. 0, 2 pi is f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx, where a0 is 1 by pi integral 0 to 2 pi f of x dx. 1 by pi integral 0 to 2 pi. What is f of x? F of x is x dx. Integral x is x square by 2 limits 0 to 2 pi. Integral x power n plus 1 by n plus 1. Integral x power 1 plus 1, 2. Now, write in the place of x 2 pi. If you write in the place of x 2 pi whole square, 4 pi square by 2. If you write in the place of x 0, 0. So finally what you will get, 1 pi get cancelled, 2 1s are 2 2s are. This pi, 1 pi get cancelled, you will have 2 pi is a0. Next we need to find an. We need to evaluate a0, an and bn. Then we get complete Fourier series. So now a0 is over. Next we need to evaluate an and bn. An equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. What is f of x? What is f of x? X integral 0 to 2 pi x cos nx dx. Here we are going to use uv formula. What is uv formula? Integral uv dx equal to uv1 minus u dash v2. So this can be evaluated like this. U is x, v is cos nx, right? Cos nx. ux, v cos nx. We need to evaluate u dash. U is there, u dash we need to evaluate. Next we need to evaluate v1 and v2. v1 value and v2 value. v1 means integral v1, integral v. v2 means integral v1. U dash means differentiation of u. v1 means integral v. v2 means integral v1. That we are going to evaluate separately very clearly. U dash differentiation of x1. v1 integral cos nx dx. Integral cos is sine, but x coefficient you need to write in denominator. Sin nx by n. v2 integral sin nx by n dx. Integral sign is minus cos nx by n square. Now ub1 u dash v2 we need to evaluate. U into v1, this is formula, ub1 minus u dash v2, this is formula. So an equal to 1 by pi uv1 x sin nx by n minus u dash v2. U dash is 1, v2 is minus cos nx by n square. Minus into minus plus cos nx by n square. Limits from 0 to 2 pi. While substituting upper and lower limit, you can remember one thing. In sine case, sine 0 is 0. Sine any pi is 0. And cos 0 is 1. Cos n pi is minus 1 whole power. So these you need to recall, most important. Because sine 0 0, sine any pi 0, here no need to substitute upper and lower limit in sine function. That becomes completely 0. No need to substitute upper and lower limit. Then you have to substitute upper and lower limit in second term, cos term only. What happens this one? 1 by pi cos. If you write in the place of x 2 pi, you will get 2n pi by n square minus cos 0 by n square. So cos n pi is minus 1 whole power n. Cos 2n pi is minus 1 whole power 2n. 2n means even number. Minus 1 whole power even number, you will have always plus 1. That's why cos 2n pi is 1, cos 0 also 1. 1 by n square minus 1 by n square. But you will get 0. an is 0. Coming to bn. Same like an only, but instead of cos we are going to replace sine. Instead of cos we are going to write sine. 1 by pi integral 0 to 2 pi f of x sin nx dx. Here f of x is x sin nx dx. Here u is x, v is sin nx. Like previous one, u is x, v is sin nx. U dash differentiation of x 1. b1 integral sin nx dx. Integral sign is minus cos nx by x coefficient here. v2 again integrate this one. v2 means integrate this one again. Integral minus cos nx by n dx minus cos nx by n square. You will get one more here. Sorry, integral cos is sine, right? Sorry, sine. Minus sine nx by n square. Simply if you have here cos, you will get sine. If you have here sine, you will get minus cos. Because this is sine minus cos, that minus is like that only. Keep as constant, integral cos sine. Now, uv1, u dash v2. vn will be 1 by pi minus x cos nx by n square minus, one more minus, plus sin nx by n square 0 to 2 pi. See here, like previous one, because sin 0 is 0, sin n pi is 0, that sin term becomes 0. Sin 0 0, sin n pi 0, this term becomes 0, that means no need to substitute upper and lower limit. For both the cases that becomes 0. So concentrate on first one only. If you write first 2 pi in the place of x, what will you get? 1 by pi minus 2 pi cos 2n pi by n square. If you write 0, 0 into anything 0. So pi cancel, cos 2n pi is 1. So you will have minus 2 by n square. Now Substitute these all in this one. Substitute a0, an values here. a0 value, an value, bn value, will get Fourier series of f of x equal to x in 0 to 2 pi. Therefore, Fourier series of f of x equal to x in 0 comma 2 pi is f of x equal to a0 by 2. a0 is 2 pi by 2 plus summation n equal to 1 to infinity. An is 0. An is 0. No need to write. So bn value is m. Bn value is m. Bn is bn minus 2 by n square sin nx. If you want, you can expand 2 get cancelled. If you want, you can expand by giving values for n 1, 2, 3 like that. You will get x expansion. F of x is x, pi plus, if you write in the, you can take minus 2 constant, pi minus 2. Write in the place of n 1 by 1 square sin x plus 1 by 2 square sin 2x, like this you will get. Okay? Any doubts you may express? These are important. In Fourier series, x and x square sums are very most important. Every time you will get these type of problems in the exam. Find Fourier series of f of x equal to x square in 0 comma 2 pi. So in 0 comma 2 pi interval, this is interval is most important. When we have to find Fourier series in 0 to 2 pi interval, we have to evaluate total a0, an, bn. 3 constants we need to evaluate. So first we are going to write Fourier series formula. Fourier series of f of x in 0 comma 2 pi is f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. So this is the formula for Fourier series of any function. In this, we need to evaluate a0, an, bn values. After evaluating a0, an, bn, we have to substitute that. Then we will get Fourier series of given function. So to find a0, we use this formula, where a0 equal to 1 by pi integral 0 to 2 pi f of x dx. What is f of x? F of x is x square. Integral x square. Integral x square is x cube by 3, limits from 0 to 2 pi. Integral x power n plus 1 by n plus 1. Integral x square, x power 2 plus 1 by 2 plus 1. X power 2 plus 1 is x cube by 3. Now write in the place of x. Now write in the place of x 2 pi. 2 pi whole cube. 2 cube is 8 pi cube by 3. If you write lower limit, that becomes 0. For 0 you will get 0. If you write in the place of x 0, you will get completely 0. Now cancel what is left over, that will be a0. So 1 pi get cancelled. 8 pi square by 3 is a0. a0 is 8 pi square by 3. Coming to an. an equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. Here f of x is x square cos nx dx. We have to use uv formula. X square is u, v is cos nx. What is uv formula? Bernoulli rule. Integral uv dx, uv1 minus u dash v2 plus u double dash v3. Because we have x square, we need to write formula up to u double dash. Up to u double dash we need to write the formula. u v1, u dash v2 plus u double dash v3. Now these we are going to evaluate. What is u here? U is x square, v is cos nx. Now find out u dash. Differentiation of x square to x. d by dx of x square to x. U double dash. Differentiation of x1 left over 2. Now v1 integral cos nx dx. Integral cos nx is sin nx by n. X coefficient you need to write in denominator. v2 integral sin nx by n dx. Integral sin minus cos nx by n into n square minus cos nx by n square. Now v3 again integrate this. If you integrate this one, integral minus cos nx by n square dx. Integral cos sin, that minus you will get as it is, sin nx by, you will get one more n square into n cube. In every time after integration you will get one n in denominator. In first time you will get one n, second time you will get one more n, so n into n square. Third time you will get one more n square into n cube. So sin becomes minus cos, cos becomes sin. So that is simple logic to find the integrals. Very simple logic. Cos becomes sin, sin becomes minus cos. Okay. Now u v1 minus u dash v2 plus u double dash v3 is formula. So an equal to 1 by pi u v1 x square into this one, x square sin nx by n, minus u dash v2 minus u dash v2, here minus you are adding, minus into minus plus 2x cos nx by n square. This is formula. I am substituting in this. u v1 minus u dash v2 plus u double dash v3. In this I am writing. u into v1 is this one. U dash into v2 is this one. U double dash into v3. So here we are having in the formula plus, but here minus. Plus into minus, minus 2 sin nx by n cube. Limits from 0 to 2 pi. So as earlier I said, sin 0 is 0. You know, sin 0 is 0, sin n pi is 0. So these two sin terms become 0. The only reason is sin 0, 0. Sin any pi, 0. Sin 0, 0, sin n pi 0. Then you don't need to substitute upper and lower limit in sin terms. Simply substitute in cos terms only. So if you substitute, what you will get? 1 by pi. Write in the place of x 2 pi. 2 into 2 pi cos 2n pi by n square. If you write 0, 0 into anything 0. So 0 no need to write. If you write 0, that becomes 0. If you write in the place of x 0, 0 into anything 0. Now pi cancel. 2 2s are 4. Cos 2n pi value is 1. Cos 2n pi equal to 1. Minus 1 whole power 2n you will get. Minus 1 whole power even number is plus 1. So finally what is left over term you are having? 2 2s are 4 by n square. This is an. An is 4 by n square. Next we need to evaluate bn. The formula for bn is bn equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. For an we will have cos, for bn we will have sin. What is f of x? F of x is x square integral 0 to 2 pi x square sin nx dx. X square sin nx dx. Again ub like previous. Integral ub1 minus u dash v2 plus u double dash v3. Using that formula, we are going to evaluate bn now. We are going to evaluate bn using Bernoulli UV formula. So what is Bernoulli UV formula? Integral ub dx equal to ub1 minus u dash v2 plus u double dash v3. Now we need to find u v1 u dash u double dash v1 v2 v3. What is u now? u is x square, u dash differentiation of x square 2x, u double dash differentiation of x1, differentiation of x1. So u is x square, u dash is 2x, u double dash differentiation of x1 2 you will get. Similarly, what is v? v is in this case sin nx, sin nx. v1 integral sin nx dx. Integral sin nx is minus cos nx by n. Integral sin minus cos. Integral sin minus cos. Now v2, again integrate this term. Integral minus cos nx by n dx. Integral cos is sin. So minus sin nx by, you will get 2 n's, n into n square. Next, v3 integral minus sin nx by n square dx. So integral sin minus cos, already you are having minus. Minus into minus plus. So cos, integral sin cos, you will get one more n, n square into n, n cube. Now we are going to write these terms like this. u v1, u dash v2, u double dash v3. Multiply u with v1, u dash with v2, u double dash with v3. What you will get? bn equal to 1 by pi u v1 minus x square cos nx by n minus u dash v2, minus into minus plus u dash 2x sin nx by n square plus u double dash v3 plus 2 cos nx by n cube. 0 to 2 pi limits. u v1, u dash v2, u double dash v3. X square into this term. Here minus, you will have minus here. Minus into minus plus. Here plus, so you will get plus only. u dash v2, u double dash v3. u v1 minus u dash v2 plus u double dash v3. As usual, this sign terms become 0. Reason you know, sin 0, 0, sin n pi 0. Because of that reason, we are not going to substitute upper and lower limit. If you substitute also, you will get 0. Now we are going to substitute 2 pi in the place of x. So first write upper limit 2 pi. If you write 2 pi whole square minus 4 pi square cos 2n pi by n plus 2 cos 2n pi by n cube minus, write in the place of x0. If you write in the place of x0, this term becomes 0. If you write here in the place of x pi 0, you will get 2 cos 0 by n cube. This is for writing x equal to 2 pi. This is for writing x equal to 0. We know cos 0 is 1. Cos 2n pi is 1. Cos 0 is 1. Cos 2n pi 1. Cos 2n pi 1. Okay, now if you substitute that values, 1 by pi minus 4 pi square by n. This is cos 2n pi is 1. So 2 by n cube. Cos 0 is 1 minus 2 by n cube. Cos 0 1, 2 by n cube you will get again. So this term get cancelled. The leftover term is minus 4 pi square by n, 1 pi get cancelled. So what you will have? Minus 4 pi by n, 1 pi get cancelled. Very clear? Do it very carefully. See the basic things which we are explaining. Sin 0 0, sin n pi 0 you need to keep in your mind. Cos 2n pi is 1. Cos 2n pi 1, how it is 1? Minus 1 whole power 2n. Minus 1 whole power even number plus 1. That's why cos 2n pi 1, cos 2n pi 1, cos 0 1. That values we substituted. In the place of cos 2n pi 1, so what you will get? Minus 4 pi square by n. Here also cos 2n pi 1, leftover term 2 by n cube. Here minus cos 0 1, cos 0 is 1, cos 0 1 means 2 by n cube, plus 2 by n cube minus 2 by n cube cancel. Bn is minus 4 pi by n. This is Bn. Already we know An. An is, we evaluated 4 by n square. A naught also we evaluated in the starting, 8 pi square by 3. If you substitute these values in Fourier series formula, you will get the answer. Finding Fourier series means evaluating A naught, An, Bn values. Now I am going to substitute these three values in Fourier series formula in this. Substituting these in f of x equal to a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. Now substitute all the values. A naught is 8 pi square by 3 by 2 plus summation n equal to 1 to infinity. What is an? 4 by n square cos nx. What is bn? Minus 4 pi by n sin nx. So here 2 1 jar, 2 4 jar, 4 pi square by 3 will get f of x is x square. Okay. So this is the way to find Fourier series of given function. You can easily evaluate, but little lengthy. You need to know integration formulas well. If you know integration formulas well, you can easily evaluate these all. Nothing difficult. Few simple basics like sin 0 is 0, cos 0 is 1, sin n pi 0, cos n pi minus 1 whole power n. These things you need to remember. And integral sin nx is minus cos nx by n. Integral cos nx is sin nx by n. These things if you can keep in your mind, so finding Fourier series is very easy one. But most important, in Fourier series, x and x square are repeatedly asking questions in every university, in every paper. Okay. Fourier series for even odd functions, especially in minus pi to pi interval. So Fourier series for even odd. What is even function? What is odd function? First we need to understand. So I am defining what is even function and what is odd function. When we can say one function is even function. If f of minus x equal to plus f of x, then f of x is even. So this is the principle which decides the given function is even or odd. The best examples for this is x square, x power 4, so on, and cos x. Because if you write in the place of x minus x, if you get same function again, then that is even. X square, write in the place of x minus x whole square. Minus x whole square is x square again. Similarly, cos of minus x is plus cos x. Cos of minus x plus cos x. That's why cos x is even. X power even numbers, one technique, x power even numbers are even functions and cos x is even. Similarly, what is odd function? Odd function. If f of minus x equal to minus f of x, then f of x is odd function. So this is the basic principle which decides the given function is even or odd. Example, x cube and sin x, because sin of minus x is minus sin x. X power odd number, x, replace x with minus x. X power odd numbers are all odd functions. Sin of minus x is minus sin x. That's why sin x is odd function. Now, whenever if you want to find Fourier series in minus pi to pi interval, Fourier series in minus pi to pi. If you want to find Fourier series in minus pi to pi, first check f of x is even or odd using these principles. So this is the most important point. In the question, you cannot find even or odd words. Simply, you will have a question, find Fourier series in minus pi to pi. Whenever if you want to find Fourier series in minus pi to pi, first check f of x is even or odd using these concepts, these techniques. If it is even function, write even function Fourier series only. Even function Fourier series. Even function Fourier series. The even function Fourier series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. You won't get sine because sine is odd. So if it is even, then you need to find a naught and a n only. A naught is 2 by pi. You will get 2 by pi. That minus pi to pi interval becomes 0 to pi. 0 to pi f of x dx. A n 2 by pi integral 0 to pi f of x cos nx dx. And similarly, if function is odd, then we write odd function Fourier series. Odd function Fourier series. That is this one. F of x equal to summation n equal to 1 to infinity bn sin nx. You don't need to find a naught an, the leftover terms in Fourier series complete formula. In Fourier series complete formula we have a naught an bn, a naught an for even, bn for all, where bn is equal to, 2 by pi integral 0 to pi f of x sin nx dx. So these are the formulas which we use to find even function Fourier series, odd function Fourier series. But when we have to apply these formulas? When you need to find out Fourier series in minus pi to pi interval, check the function is even or odd. If it is even, apply even function Fourier series formulas, this one only. If it is odd, use these formulas. If it is not even, not odd, then you need to evaluate complete a naught, a n, b n. Example for the function which is not even, not odd, e power x. E power x is not even, not odd. For that you have to evaluate complete. X minus x square, f of x equal to x minus x square, important problem in minus pi to pi. There x minus x square is not even, not odd. Then we have to evaluate complete a naught, a n, b n. If it is even or odd, that corresponding formula you are going to apply. If it is not even, not odd, you have to evaluate complete Fourier series, which we discussed in 0 to 2 pi. A naught by 2 plus a n cos nx plus b n sin nx. Complete one you need to do when it is not even or odd. Are you clear? Any doubts you may ask. Find Fourier series of f of x equal to x in minus pi comma pi. Whenever if you want to find Fourier series in this interval, minus pi comma pi interval, you have to check first whether the function is even or odd. If it is even, apply even Fourier series. If it is odd, apply odd Fourier series. If it is not even, not odd, write complete Fourier series. First we will check. Given f of x equal to x. But we all know that x power odd number is odd function. X power 1 or f of minus x, like this you need to check. F of minus x, right in the place of x minus x. Minus f of x. So, which is odd? Right in the place of x minus x. Then what you will get? Minus x. What is x? F of x. If f of minus x equal to minus f of x, that is odd function. Otherwise, small technique is x power 1, x power 3, x power 5 are odd functions. You can use that technique. Now, write odd function Fourier series. Odd function Fourier series. What is odd function Fourier series? We know f of x equal to summation n equal to 1 to infinity bn sin nx, where bn is bn equal to 2 by pi integral 0 to pi f of x sin nx dx. 2 by pi integral 0 to pi f of x is x sin nx dx. Now x is u, sin nx is v, uv. We know this formula, integral uv, integral uv dx, uv1 minus u dash v2 enough. Because we have x. If we have x square, u double dash v3 also you need to write. U equal to x, v equal to sin nx. U dash, differentiation of x1, v1 integral sin nx. Integral sin nx is minus cos nx by n. v2 integral minus cos nx by n. Integral cos sin minus sin nx by n square. Integral cos plus sin, that's why you will get this minus again. Integral sin minus cos. Now u v1 u dash v2. So now Bn equal to 2 by pi u v1 x into this one minus x cos nx by n minus u dash v2, but already we have minus here. In the formula we have minus, v2 has minus. Minus into minus plus, that is plus sin nx by n square, limits 0, pi, 0 to pi. Are you clear? Any doubts you may ask? U v1 minus u dash v2. Now substitute upper limit and lower limit. But we know sin 0 is 0, sin n pi is 0, sin 0 is 0, sin n pi is 0. That's why that complete term becomes 0. No need to substitute upper and lower limit. Now write in the place of x pi minus pi cos n pi by n. This 0 case becomes 0. No need to write lower limit case. If you write in the place of x 0, 0 into anything 0. Now this pi get cancelled. Minus 2 by n, cos n pi is minus 1 whole power n. Cos n pi equal to minus 1 whole to the power of n. So this is Bn. Now finally, what is Fourier series? So Fourier series of f of x equal to x in minus pi comma pi is f of x equal to summation n equal to 1 to infinity bn sin nx. Simply write bn value. Bn value. Summation n equal to 1 to infinity bn is minus 2 by n minus 1 whole power n sin nx. Simply write in the place of bn value. Okay? Any doubts you may express? Find Fourier series of f of x equal to x square in minus pi comma pi. So given f of x equal to x square in minus pi comma pi. So whenever if you want to find Fourier series in minus pi comma pi, first check whether that is even or odd. You know, x power even number is even. So f of x is even function. Or you can check like this: f of minus x equal to minus x whole square plus x square, that is f of x. F of minus x is f of x is even. So if it is even, we are going to write even function Fourier series. Even function Fourier series. What is even function Fourier series? F of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx, where a0 equal to 2 by pi integral 0 to pi f of x dx. 2 by pi integral 0 to pi. What is f of x? F of x is x square. So write that x square here, x square dx. We know that integral x square is x cube by 3. So 2 by pi x cube by 3 limits 0 to pi. If you write in the place of x pi, what you will get? 2 by pi pi cube by 3. So 1 pi get cancelled. 2 pi square by 3 is a0. So now we need to evaluate an. What is formula for an? An equal to 2 by pi integral 0 to pi f of x cos nx dx. What is f of x? 2 by pi integral 0 to pi x square cos nx dx. X square is u, v is cos nx. Again we need to use integral uv formula. Integral uv, we know that formula. That formula we are using. Integral uv dx, uv1 minus u dash v2 plus u double dash v3, because we have u as x square. If you have x square, write up to u double dash. If you have x, write formula up to u dash. Now uv is x square, u dash, differentiation of x square to x, differentiation of x1, u double dash 2. Now v equal to cos nx, v1 integral cos nx. Integral cos nx is sin nx by n. v2 integral sin nx by n dx. Integral sin nx minus cos nx by n square. Next v3. v3 equal to integral minus cos nx by n cube. So integral cos sin, that minus you will get as it is, sin nx by n cube. Now u into v1, u dash v2, u double dash v3 is formula. Now we are going to find vn. 2 by pi u v1 x square sin nx by n minus u dash, minus here minus, plus 2x cos nx by n square, plus here minus, minus into plus minus 2 sin nx by n cube, 0 to pi. Now we all know that sin 0 is 0, sin n pi is 0. That means this total term becomes 0. The reason is sin 0, 0, sin n pi 0. So no need to substitute upper and lower limit in sin terms. So substitute only in cos. Here also no need to write 0. 0 into anything 0. Write pi only. 2 pi cos n pi by n square. Pi cancel. Cos n pi is minus 1 whole power n. 2 2s are 4. 4 by n square minus 1 whole power n, because cos n pi value. Cos n pi is minus 1 whole power n. Vn value. So finally Fourier series is f of x equal to summation n equal to 1 to infinity bn sin nx. a0 by, sorry, this is an this is. So f of x equal to complete Fourier series a0 by 2 plus summation n equal to 1 to infinity an cos nx. Okay, now we need to substitute a0 and an value. a0 is 2 pi square by 3 by 2 plus summation n equal to 1 to infinity an is 4 by n square minus 1 whole power n cos nx. f of x is x square. Here 2 get cancelled. So like this one can easily evaluate Fourier series of any function in minus pi to pi by verifying whether it is even or odd. Any doubts you may express. Half range Fourier series, especially in the interval 0, pi. We discussed in minus pi comma plus pi, that is complete interval minus pi to pi. Now we are finding half range. Range is half, 0 to pi. In minus pi to pi interval 0, pi is half. So in this interval, what is Fourier series? In half range we have two Fourier series. One is cosine series, another one is sine series. What is half range cosine series? Cosine series. Half range cosine series. Cosine series is this one, f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. Half range cosine. So here we will have a naught and a n only, and we won't have sine terms, only cos terms. Where a naught equal to 2 by pi integral 0 to pi f of x dx. A n equal to 2 by pi integral 0 to pi f of x cos nx dx. Similarly, we have another series which is called sine series. F of x equal to summation n equal to 1 to infinity bn sin nx, where bn is 2 by pi integral 0 to pi f of x sin nx dx. So these are half range Fourier series formulas. If you want to find half range cosine series, we are going to use this. Half range sine series, we are going to use this. But if you observe, previously we discussed one topic, even odd function. There you find the same formulas. The interval only different. There if you have minus pi to pi interval, we check whether the function is even or odd. If it is even function Fourier series we write. If it is odd, we will write odd function Fourier series. There, what is even function Fourier series we said? The same one now we are learning as cosine series. The odd function Fourier series which we discussed there, the same one we are discussing as sine series. But the difference between these two is, here interval is 0 comma pi, their interval is minus pi comma pi. Here clearly find cosine series, find sine series, like that we will have to say. But there you have to decide whether we have to use these formulas or these formulas. If it is even, we go for this. If it is odd, we apply this. Okay? Any doubts you may express? Find half range cosine series of f of x equal to x in 0 comma pi. In 0 comma pi interval, we need to find half range cosine series. So to find half range cosine series, first write half range cosine series formula. Half range cosine series. Half range cosine series is f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx, where a naught equal to 2 by pi integral 0 to pi f of x dx. 2 by pi integral 0 to pi, what is f of x? F of x is x in the given problem, dx. Integral x is x square by 2, integral x power n plus 1 by n plus 1, limits 0 to pi. Now write in the place of x pi square by 2. If you write 0 by 2, 0, no need to write lower limit. Now 2 get cancelled, 1 pi get cancelled, a naught you will get pi. A naught is pi. Next we need to find an. An formula we know. An equal to 2 by pi integral 0 to pi f of x cos nx dx. F of x is x, 2 by pi integral 0 to pi x cos nx dx. Now take this one as u, this one as v. Integral uv formula, integral uv dx, uv1 minus u dash v2. Because we have x, we need to write formula up to u dash, Bernoulli rule of uv. So now u is x, v is cos nx, u dash differentiation of x 1, v1 integral cos nx dx, integral cos nx is sin nx by n, integral cos sin. Next x coefficient we need to write in the denominator. Next v2 integral sin nx by n dx, integral sin minus cos. So you will have here minus cos nx by, you will get one more n into n square. Now we need to apply this formula uv1 u dash v2. Using this we will get an value, an equal to 2 by pi x sin nx by n minus u dash v2. Here minus, here you will have one more minus, minus into minus plus cos nx by n square, limits 0 to pi. So if you write in the place of x 0 sin 0 0, if you write in the place of x pi sin pi 0. So we are not going to substitute upper and lower limit for sin terms, that becomes completely 0. So we are going to substitute pi and 0 in second term only. 2 by pi cos n pi by n square minus cos 0 by n square. We know that cos n pi is minus 1 whole power n, cos 0 is 1. Cos n pi minus 1 whole power n, cos 0 1. Now n square you can take it as common, 2 by pi n square, cos n pi minus 1 whole power n, cos 0 1. So for n odd, what happens? If you write in the place of n odd number, minus 1 will be minus 1, minus 1 minus 1 minus 2. If you write in the place of n even, minus 1 whole power even number is 1, 1 minus 1 0. So that's why what I am doing, I am writing this one like this. This is 0 for n even, and for all function this becomes minus 2 minus 4 pi by n square for n is odd. So that's why while writing Fourier series you will keep odd numbers in the expansion. That means like this, f of x equal to a naught by 2, a naught is pi, pi by 2 plus summation n equal to 1 3 pi, so on to infinity. An cos nx, an is minus 4 pi by n square cos nx. So like this one can easily evaluate half range cosine series and sine series. Sine series we will discuss in the next problem. This is cosine series. Find half range sine series of f of x equal to x square in 0 comma pi interval. Sine series we need to find for f of x equal to x square function. So we know what is sine series formula, half range sine series. Half range sine series is sine series of f of x. F of x equal to summation n equal to 1 to infinity bn sin nx. F of x equal to summation n equal to 1 to infinity bn sin nx, where bn equal to 2 by pi integral 0 to pi f of x sin nx dx. So here bn is enough to evaluate. So bn is f of x sin nx. What is f of x? F of x is x square sin nx dx. Now use uv formula. uv integral uv dx equal to uv1 minus u dash v2 plus u double dash v3. Because we have x square, you need to write formula up to u double dash. So here u is x square, v is sin nx, u dash differentiation of x square 2x, u double dash differentiation of x 1 2. Like that, find out v1 v2 v3. v1 integral sin nx dx minus cos nx by n. v2 integral minus cos nx by n dx. Integral cos sin, that minus you will get as it is, sin nx by n square. v3 integral minus sin nx by n square dx. Integral sign minus, so one more minus you will get, minus into minus plus, cos nx by n cube. Now we need to do like this: u v1, u dash v2, u double dash v3. u v1, u dash v2, u double dash v3. So now we are using that. bn equal to 2 by pi u v1 minus x square cos nx by n minus u dash v2. Here minus you are having, here you are having one more minus. Minus into minus plus 2x sin nx by n square plus u double dash v3. u double dash is 2, v3 is cos nx by n cube v3. Now you need to multiply these two, because you have here plus, you will get same sign what you are having in formula, that sign only will get, plus only. 2 into cos nx by n cube, cos nx by n cube, limits 0 to pi. We all know that sin 0 is 0, sin n pi is 0. So this term becomes completely 0. No need to substitute upper and lower limit in sin term. Now substitute upper and lower limit in cos terms, two terms. If you write pi, minus pi square cos n pi by n plus 2 cos n pi by n cube minus, write in the place of x0. If you write in the place of x0, the first term becomes 0 plus 2 cos 0 by n cube. Cos 0 is 1, cos n pi is minus 1 whole power n. So what you will get? 2 by pi minus pi square minus 1 whole power n by n plus cos n pi is minus 1 whole power n. Cos n pi minus 1 whole power n minus, minus into plus minus, cos 0 1, cos 0 1, 2 by n cube you will get. Okay, this is bn value. If you want, you can simplify, taking minus 1 whole power n common from these two terms, or you can take n cube common, 2 common from the two terms. 2 by pi minus pi square into minus 1 whole power n by n. Here you can take 2 into minus 1 whole power n. Only 2 common. 2 by n cube common. 2 by n cube common. Minus 1 whole power n minus 1. Okay, that is Bn. Now substitute that Bn value in Fourier series. F of x equal to summation n equal to 1 to infinity Bn sin nx. Summation n equal to 1 to infinity Bn is here 2 by pi minus pi into minus 1 whole power n by n plus 2 by n cube minus 1 whole power n minus 1 into sin nx. Okay, like this one can easily evaluate half range Fourier sine and cosine series for the given functions. Okay, find half range sine series for f of x equal to e power x in 0, 5. So e power x is different one. Every time for evaluating a n b n we are using uv, integral uv. But if you have e power x, we are not going to use uv rule. E power x sine, e power x cos, we are not going to use uv. We have one standard formula, integral e power ax sine bx, integral e power ax cos bx. That formulas we are going to use. So now coming to the actual topic, find half range sine series. So you know the sine series formula in Fourier, half range sine series f of x equal to summation n equal to 1 to infinity Bn sin nx, where Bn equal to 2 by pi integral 0 to pi f of x sin nx dx. So 2 by pi integral 0 to pi f of x is here e power x sin nx. So here to evaluate this we are going to use this formula, integral e power ax sin bx dx equal to e power ax by a square plus b square a sin bx minus b cos bx. A sin bx minus b cos bx. So that is the formula we are going to use to evaluate integral e power x sin nx. In this case, a is 1, b is n. B value is this one, a value is here. Now if you use that formula, 2 by pi e power x by a square plus b square, 1 square plus n square. A sin bx, a is 1, b is n sin nx minus b cos n cos nx. Limits 0 to pi. As usual, we are not going to substitute upper and lower limits in sine term. Sin 0 0, sin n pi 0. So that is the reason. Now I am going to write first in the place of x pi. If you write in the place of x pi, e power pi by 1 plus n square, sin n pi 0, n cos n pi minus, this is upper limit. Okay, this is upper limit. Next, coming to lower limit, write in the place of x 0. If you write in the place of x 0, e power 0 by 1 plus n square sin 0 0 cos 0 1 n cos 0. So here you need to remember few basic formulas, that is e power 0 is 1, sin 0 is 0, cos 0 is 1. These things we need to remember. and cos n pi is minus 1 whole power n. Cos n pi is minus 1 whole power n. These already we discussed for so many problems, just I am recalling all the formulas. E power pi is e power pi, that will be like that only. E power pi by 1 plus n square will be like that. Here cos n pi minus 1 whole power n, so minus n into minus 1 whole power n. This is for upper limit. Coming to lower limit, e power 0 is 1. 1 by 1 plus n square. Minus into minus plus cos 0 1. So n, which we can take it as common. We can take n by 1 plus n square common. If you take n by n plus 1 plus n square common, or if you take minus n by 1 plus n square common, here minus n we do as common. E power pi minus 1 whole power n minus 1. This total term is common. Plus 1, because the minus is common, right? You will get plus. E power pi minus 1 whole power n plus 1 will be Bn. Now we need to find Fourier series. So half range sine series. Sine series f of x equal to summation n equal to 1 to infinity Bn sin nx. So we need to write in the place of Bn value. Summation n equal to 1 to infinity minus n by 1 plus n square e power pi into minus 1 whole power n plus 1 into sin nx. So this will be half range sine series of e power x. Okay. So whenever if you get e power x, don't use uv. Think about these formulas. If you have cos, you will get cos sine. If you have e power x, use these type of formulas. That is only difference. Find Fourier series. Now we are going to discuss Fourier series in constant interval. Constant interval means other than these intervals. Till now we discussed Fourier series in the interval where we have pi. But now we won't find this pi. We will have constant numbers like these type of intervals. Minus 1 to 1, minus 2 to 2, 0 to 3. If we have numbers other than pi. But till now we discussed 0 to pi, minus pi to pi, 0 to 2 pi. But now we are going to discuss the interval which we won't find these two. We won't find pi. When you have a constant number like this, what is Fourier series? In this interval, Fourier series of f of x in 0 to 2l we will discuss first. 0 to 2 pi interval, that type of interval, 0 to 2l. In this, Fourier series is minor difference f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos n pi x by l plus bn sin n pi x by l. So you can easily observe what is the actual difference between the Fourier series in pi interval and constant interval. So this is the difference. You can find this. This one will be the new thing. The remaining you know. That is only new thing here you are learning. General Fourier series is a naught by 2 plus summation n equal to 1 to infinity a n cos nx bn sin nx. What extra we are adding here? Pi by l. So that pi by l we need to add. That if you can remember, you can easily find Fourier series in constant interval. Here L plays key role to evaluate a naught, a n, bn. How we write pi there? Like that here. So if the interval is 0 to 2l, then Given interval will be compared with 2L. What I am saying, for example, this is the interval 0 to 3. Then, how you evaluate L? You have to equate 2L to 3. 2L3, L3 by 2. Are you clear? But if it is a half range, you can take L3 directly. That we will discuss now itself. When 0 to 2L is the interval, if 0 to 3 is given interval, then you need to compare 2L with 3. L you need to find. L plays key role. If L is wrong, everything will be wrong. So you should be very careful while evaluating L. Okay, but there is no confusion. Simply Fourier series, find Fourier series in 0 to 3, then you need to equate 3 to 2L. Find half range Fourier series in 0 to 3, then L will be 3. Half range direct you can equate it to L. If it is not half range, you have to equate it to 2L. That is only the difference. Now coming to A0, where A0 equal to 1 by L integral 0 to 2L f of x dx. An 1 by L integral 0 to 2L f of x. Here you will get same term cos n pi x by L. That pi by L extra. Bn equal to 1 by L integral 0 to 2L f of x sin n pi x by L dx. Bn value. So this is about 0 to 2L interval. F of x cos n pi x by L, f of x sin n pi x by L dx. Coming to the half range, in the same, if it is half range, how you are going to evaluate? Half range Fourier series. Half range Fourier series in 0, L. So that's what I said. If you have half range, then compare the given interval directly to the L. That's what I am saying. For example, the previous case, if you have L 0 to 3, then L will be 3. Half range direct you can take that value to L. If it is not half range, you need to equate this one to 2L. Again, half range we have two series, cosine and sine series. Cosine series. Half range cosine series. So cosine series is this one, f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by n, where a0 equal to 2 by L integral 0 to L f of x dx. An equal to 2 by L integral 0 to L f of x cos n pi x by L dx. Now sine series. Sine series. In sine series you will get like this. F of x equal to summation n equal to 1 to infinity bn sin n pi x by n. Only bn you will have in sine series, where bn equal to 2 by L integral 0 to L f of x sin n pi x by L dx. So this is half range Fourier series in constant interval, that is 0 to L. For example, if you have an interval minus L to L, Minus L to L means, for example, minus 2 to 2, minus 1 to 1, minus 3 to 3, like this. So then L will be 2 directly, minus 1 to 1, L1, minus 3 to 3, L3. But if you have minus L to L, you need to check whether the function is even or odd, like minus pi to pi. If it is even, you need to apply even function Fourier series. If it is odd, you have to apply odd function Fourier series. But where is even function Fourier series, odd function Fourier series? That is very easy. Even function Fourier series and cosine series are same, that you know. So this we can take it as even in another way. This we can take it as odd. In which interval? Minus L to L. Minus L to L. Minus L to L. The same formulas we repeat for even function and odd function. So even function Fourier series is nothing but cosine series. Odd function Fourier series is nothing but sine series. But the question is different. Find Fourier series of f of x in minus L to L. He won't mention find cosine sine. If it is minus L to L, you have to identify whether we have to apply this Fourier series or this Fourier series. If it is even, you have to follow this. If it is odd, you have to follow this. So keep one most important point in this, L. L plays key role. Find Fourier series in 0, 3. Then you have to equate 3 to 2L, L is 3 by 2. The same question if you have like this. Find half range Fourier series in 0 to 3. Then L will be 3 directly. Find Fourier series in minus 3 to 3. Then L is 3. Minus 2 to 2, L 2. There no confusion. You have little confusion in 0 to 2L and in 0 to L. But there is no confusion actually, because half range he will mention. If it is half range cosine sine, you can find L directly. So keep this point in your mind. If L is wrong, everything will be wrong. This is also important. We are getting an exam in external also. Find half range sine series of f of x equal to 1 in 0, L. This is important. Interval is not 0, pi. Generally, half range sine series we discussed already in 0, pi. But now the interval is 0, L, constant interval. When we have a constant interval, then formula to find half range sine series is half range sine series is f of x equal to summation n equal to 1 to infinity bn sine n pi x by l. Here I will place key role to find any constant like a0, a and bn. So find out here, because this is a half range, so L will be compared to directly L. So L equal to L. In half range, this will be compared to 0 to L only. So in the place of L we have L. So L equal to L. Next, we need to find Bn, where Bn equal to 2 by L. 2 by L integral 0 to L f of x sine n pi x by L dx. So now what is f of x? F of x is 1. F of x is 1. Write in the place of f of x 1. Sine n pi x by L dx. 1 into sine n pi xl. Sine n pi xl only. 1 into anything, 1 only here. Except 0. 2 by L. Integral sine we know. Integral sine x is minus cos x. Integral sine nx is minus cos nx by L. So using this formula, integral sine n pi x by L minus cos n pi x by L by, what is x coefficient we are having? That one we need to write in denominator. This one. Write that complete term in denominator as it is. What you will get? N pi by L. x coefficient you need to write in denominator. This n pi by l, if you take here, that becomes l by n pi, like this, 0 to l limits, 2 by l into l by n pi. So now, if you want, you can take this minus outside, minus here. Now only cos n pi x by l you are having. Write in the place of x l. If you write in the place of x l, l cancel. What is left over? Cos n pi. Minus lower limit. Write in the place of x 0. If you write in the place of x 0, cos 0. Cos 0 we know 1. So you will get cos 0. And we know cos n pi is minus 1 whole power n. Cos 0 is 1. Cos n pi is minus 1 whole power n. Now we are going to substitute that values here. L get cancelled. What is left over? We'll see in the next step. Are you clear here? Any doubts you may ask. Integral sin nx minus cos nx by l. That means x after integration, x coefficient you need to write in denominator. So what is x coefficient we are having? N pi by l. That I written in denominator. Integral sign minus cos the same you will get. Denominator fraction if you take to numerator, that will be reverse. So denominator n pi by l, if you take that one here, that will be written in reverse. That is, numerator becomes denominator, denominator becomes numerator. L cancel. This minus I written here. This minus I written here. Now I am substituting in the place of x l. If you write in the place of x l cancel n pi. If you write in the place of x 0, 0 into anything 0. Now we are going to substitute these values here. Cos 0 1, cos n pi minus 1 whole power n. Substitute. So Bn equal to minus 2 by n pi. Cos n pi minus 1 whole power n, cos 0 1. So this is Bn, but if you have in the place of n even number, minus 1 whole power even number, plus 1 minus 1 0. That's why Bn has two possibilities. When n is even, that becomes 0. When n is odd, minus 1 whole power odd number is minus 1. Minus 1 whole power odd number minus 1. Minus 1 minus 1 minus 2. Minus 2 into minus 2 plus 4. 4 by n pi. Whenever n is odd. That means while writing this expansion, you don't need to write n 1 to infinity. You can skip even numbers. 1, 3, 5, so on infinity. We are going to write only odd numbers in the expansion. If you write even number, you will get 0. So now the Fourier series is f of x equal to summation n equal to 1 to infinity Bn sin n pi x by l. What is Bn now? Here what I am saying, instead of writing 1 to infinity, we are going to take only odd 1, 3, 5, so on infinity. In this interval, Bn is 4 by n pi sin n pi x by l. Okay, if you want, you can give 1, 2, 3 for n, you will get the exact expansion. What I am saying, you can take 4 by pi. Now write 1, 3, 5, 2 terms up to infinity no need. If you write in the place of n 1, you will get 1 by 1 1. So sin pi x by l. If you write in the place of n 2, what you will get? 1 by 2 sin 2 pi x by l plus so on. This is Fourier series half range sine series of f of x equal to 1 in 0, l. So important problem only. One time we got for 5 marks in external. Express f of x equal to x as half range cosine series in interval 0, 2. This is constant interval. When you are finding half range Fourier series in constant interval, the formula to find cosine series, we don't have pi in the interval. So when you have constant interval, you need to find Fourier series like this. Fourier series of f of x in 0, L is f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos n pi x by n. Now we need to find a0 an. Before going to find a0 an, first evaluate what is n. When you have half range cosine series, then you can compare given interval directly to standard interval 0 to L. Now you can find out L very easily. L is 2, right? Direct L. If it is not half range Fourier series, then you have to compare this one with 2L. 2L equal to 2, L equal to 2 by 2, 1. So now L is 2. A0 formula. A0 equal to 2 by L integral 0 to L f of x dx. Now f of x is x, L is 2. 2 by 2 integral 0 to 2. F of x is x. So 2 get cancelled. Integral x square by 2 limits from 0 to 2. If you write in the place of x 2 square by 2, so you will get 2. A0 is 2. A0 is 2. Next we need to find an. An equal to 2 by L integral 0 to L f of x cos n pi x by L dx. F of x is x, L is 2. L is 2. F of x is x cos n pi x by 2 dx. Now we are going to use uv formula. Integral uv. X is u, v is cos n pi x by 2. Now write what is u. u is 2 by 2 cancel 1. Formula is integral uv dx equal to uv1 minus u dash v2. u is x, v is cos n pi x by 2. n pi x by 2. Now find out u dash 1 v1 integral cos n pi x by 2 dx. Integral cos sin n pi x by 2 by n pi by 2. X coefficient you need to write in denominator. This one you need to write in denominator. If you write in denominator, you will get n pi by 2. If you get that one as coefficient, that becomes reverse. That means n pi by 2 will be 2 by n pi. 2 by n pi. Now again find v2. v2 equal to 2 by n pi into integral sin n pi by x by 2 dx. If you integrate sin, you will get minus cos. Integral sin minus cos. Minus cos n pi x by 2. Again, this n pi by 2 you will get in denominator. Already you have 2 by n pi as coefficient. You will get one more 2 by n pi. That means 2 by n pi into 2 by n pi, 4 by n square pi square, integral sign minus, that will be there. 2 2s are 4. Now we are going to apply this formula, integral uv1 minus u dash v2. So apply to find an. An equal to uv1 2x by this one, x into this one, 2x by n pi sin n pi x by 2 minus, here minus, plus 4 by n square pi square cos n pi x by 2. Limits from 0 to 2. Now we all know that sin n pi is 0, sin 0 is 0. If you write in the place of x2, you will get sin n pi, that becomes 0. If you write in the place of x0, you will get sin 0. Because Sine 0 is 0. The reason we are not substituting upper and lower limit is this one. Sine 0 is 0. Sine n pi is 0. So because sine 0 is 0, sine n pi is 0, we are not going to substitute upper and lower limit in sine term. We are going to substitute upper and lower limit in cos term only. Write in the place of x2, what you will get? 4 by n square pi square is constant. If you write in the place of x2, cos n pi. If you write in the place of x0, cos 0. Now we all know that cos n pi is minus 1 whole power n, cos 0 is 1. Cos n pi minus 1 whole power n, cos 0 1. So what you will get? 4 by n square pi square minus 1 whole power n minus 1. If you get like this, you will check if it is even or odd. For n even, what happens? Minus 1 whole power even number is plus 1. Plus 1 minus 1 0. That's why n has two possibilities. When n is even, this becomes 0. When n is odd, minus 1 whole power odd number minus 1, minus 1, minus 1, minus 2. Minus 2 into 4 minus 8. Minus 8 by n square pi square when n is odd. So finally, the required Fourier series is f of x equal to a naught by 2. A naught is 2. 2 by 2 plus summation n equal to 1 to infinity. An, here I am writing odd 1, 3, 5 infinity. N equal to 1, 3, 5 infinity. In that interval, n is minus 8 by n square pi square cos n pi x by L 2. Here 2 get cancelled, you will have 1. So like this one can easily find out Fourier series in constant interval other than minus pi to pi, 0 to 2 pi intervals. Okay.